include iostream, include quicksort.h. When we use the line include quicksort.h, we are requesting that all of the content from the header file be copied into the including file. That makes the content from the header file available for use in our code file. In the main function, the array is initialized as a value with data type int. The size of the array that matches the value included between the braces. Print before sorting. Print function is declared with argument value and the number of array size, which is for quick sort value 0, 3. 0 is the first index and 3 is the last index. Print after sorting, and the print function is declared with argument value and the number of array size, which is for array return 0. For the quick sort function with void data type, it declared with int arr, int left, and int right. First, quick sort determines something called a pivot, which is a somewhat arbitrary element in the collection. In this, normally to find the pivot, we use the formula arr left plus right divided by 2. But for this function, we use int pivot equal to arr right. Next, using the pivot point, it partitions or divides the larger unsorted collection into two smaller lists. It uses some smart logic to decide how to do the partitioning. First, start a pointer. The left pointer at the first item in the array is initialized as a I, and the right pointer at the last item in the array as a j, and then int temp. While I is less or equal to j, while the value at the left pointer in the array is less than the pivot value, move the left pointer to the right and add 1. Continue until the value at the left pointer is greater or equal to the pivot value. While the value at the right pointer is greater than the pivot value, move the right pointer to the left and subtract it by 1. Continue until the value at the right pointer is less than or equal to the pivot point value. If the left pointer is less than or equal to the right pointer, then swap the value at this location in the array. As I mentioned before this, if left is less than j, quicksort arr left j. If I less than right, quicksort arr I right. Move the pointer to the right by 1 and the right pointer to the left by 1. We have to repeat the same step until the list is being sorted. For example, the value is 0351 and we randomly pick a pivot number, which is I choose 1 as a pivot number. Since the value passing to quicksort is 0 and 3, 0 is pointing to the first index of the array and 3 is pointing to the last index of array. Because array size is 4, so maximum will be 4 minus 1 equal to 3. So during the first iteration, the sorting will be 0351. During the second iteration, the sorting will be 0153, and during the third iteration, the sorting will be 0135. For print function, int a is the value, int n is the array size. For int I equal to 0, I less than n, and I will be increased by 1. It will print out the array I, which is the index number, and it will print the value. So the result is before sorting, array index 0 is 0, array index 1 is 3, array with index 2 is 5, array with index 3 is 1. After sorting, array with index 0 is 0, array with index 1 is 1, array with index 2 is 3, and array with index 3 is 5.
So in section 2, we are going to do searching. We have given the code for binary search here and our main function here. Then we will first create a header file named binary search and copy the code of the binary search in this function. Then in our main function, we will include our binary search header file here. So when we run this program, we will get this result here. So how the code execute? We will see first here, we will declare an array integer data with this in order integer here. Then we will instantiate our binary search of object name list here and pass in the array data and the size of the array. Then we will print out our array by calling the function display that is inside our binary search header file here. So we will get our result here, the element inside our array. So in here we are going to search an integer number 88, and here we declare the position, which will return the integer number 88 here, which we want to know the index of this integer number inside our array by calling the function find here. Then we will go into our find function in our binary search header file here. So we have received 88 here. Then we declare top, bottom, middle position, and a boolean expression exists. So we will first declare exists as false. Then our bottom will be 0. This bottom is 0, and then the top will be num data minus 1. Num data is our size of our array is 10. Then minus 1 will be 9. So 9 will be assigned to our top. Then we will loop this using while loop. So if top is greater than or equals to bottom, that is 9 greater than or equals to 0. So we will assign our middle with our array index of the middle of the array, that is 0 plus 9 by 2, which is 4.5. Since our middle is integer, so the integer number will be 4, we assign to middle. Then we check if the 88 is greater than the array of index 4 element, which is 54. Yes, so our bottom here, bottom will be assigned with middle plus 1, that is 5. Then it will keep looping until else the axis true, means our element is found in our array, and the position here will return the index of our array position. So in this case, we want to find 88 that is inside our array here. So when it's found, then the bottom will be equals to top plus 1, that it will terminate the loop, because if our while loop, the top is greater than equals to bottom, then it will keep looping. But now our bottom will be greater than our top, so it will terminate the loop. Then it will check if the is not exist, means it's not true, then it will assign -1 to our position. Since our exist is true, so it will then return the position that is our index of number 88. Then our result here is we get the data 88 is found at the position 7. Next, we go into section 3 exercise. We want to create a new project workspace here, and in the project should contain 2 algorithms. That is our quicksort.header file and our binary search header file. And we write a program to sort element and then search the element from an array based on the given key. And the array can be either in order or unordered, show all the program calls and output. So here we already insert our binary search header and our quicksort header in our header files. Then we will create our main function here, and we include the quicksort header file and our binary search header file here. Then we will first declare the size of our array, that is 10, and the array here we have 5, 9, -3, 2, -1, 6, 8, 0, 3, -5 in an unordered array. Then we will first print out our array before sorting. Okay, before that we will like to run our code. So this is our code result. Here we can see we will print out our array by calling our function print here from the quicksort function here. So we'll print out our array, and this one is our result. The array is in unorder. Okay, then we will quicksort by passing the array element and the index of our the first index of our array and the last index of our array. Then here we will go into our quicksort function here, and the algorithm is the same as in our section 1. So after we quicksort, then we will print out again our array here. We will get the array in order -5, -3, -1 until 9. Then we will print out again our array as called array list. So we will print out again our array in a linear form here. Then we want to find our one of the element that is 6 in our array. So we want to know the index of our position of this integer number 6. So now we will use our header file binary search. So, and in here we have declared the position that we return and assign with the find function. And we will go into our find function here. It's the same. It will find and receive the integer number here, and it will keep looping while loop until it found the position of our integer inside our array, whether it is not. If yes, then it will return the index of our array. Then here we will get our result. Data 6 is found at the position 7 here. So that's all. Thank you.